Okay, so I'm going to be demonstrating how to draw a ray diagram for a convex lens. So you're going to start with your straight line, your focal points on either side. A convex lens looks like that. You have an object down here. The first line you're going to do is going to be from the top of the object straight through the center of the lens. And so you can use any straight edge like a ruler and just line it up from top of the object straight through the middle. The second one, you're going to go from the top of the object parallel to the center of the lens, and then you're going to refract it through the focal point on the opposite side. And then the third one you're going to do is going to be from the top of the object, and it's going to angle towards the focal point on the same side to the center, and then it's going to refract parallel out the other end. Once you have all three lines, you're going to see that there's a point where all of them intersect, and that is going to be where your image is. And so from that, using a ruler, you can calculate your image height, your image distance, and then from there you can get magnification and so on. You know, for a concave lens, it's going to be almost the exact same setup. That's what the lens looks like rather than a convex one. You still have two focal points and your object. So the first one you're going to do is the exact same. You're going to go from the top of the object through the center of the lens to the other side, using your straight object. The second one you're going to do is going to go from the top of the object parallel to the center, and then it's going to be refracted from this first focal point. So it's going to go straight and then upward. It's going to be that one. Now the third one, you're going to go angle it from the top of the object to the opposite side focal point, and then just to the center. So you're going to line that up from the top of the object to the focal point on the other side. Draw that just to the center of the mirror or of the lens, and then it's going to go parallel on the other side when it refracts. And there's your diagram. And from looking at it, you can see that all of these refracted angles do not ever intersect to form that image. So then you have to extend the refracted rays backwards with dotted lines to show that they are virtual. And when those dotted lines intersect, you'll have your image. So you can see that the image forms right about there. Once you bring your dotted lines back, it's kind of hard to see. And then it's just barely above the normal line. And so you can tell it's virtual because it is on the same side as the object of the lens. And that it is upright because it's above that normal line. So from there, you can also calculate image distance, image height. It's just going to be a virtual image versus the real image that's inverted from the convex example.